Hi, this is Marcelino Gutierrez. Welcome to the CIER-UNF-015 2022. I'm gonna tell you about a work that we did with a group of colleagues, and its name Aligning System for a pick and place BGA soldering equipment. Thank you for the invitation, and let's start. Pick and place systems for BGA semiconductor soldering machine are systems very required nowadays because with these systems we can have these mobile devices like tablets, cell phones, computers, and many other portable devices, and the density of circuits that we can have, but now in a smaller and thick board, it's been growing and growing and growing and growing, and all of it has been thanks to the capability of these machines to solder these devices again. Well, to start these pick and place systems, they need a lightning system inside of them to have a reference and start and know where to start, like a home, and where to know where to start picking and placing all the semiconductors from, for example, 8 boxes to the main board, which is going to be placed into an oven later, but into an oven to have this soldering in a high temperature in order to solder the components to the main board. And as I said before, for example, to have a reference, they need to have to have a spot in order to know where to start placing semiconductors. For that thing, there are, for example, image recognition or position systems, which basically select or find the reference and tell the computer where to start their coordinates, and then later on the XY table starts moving to go and get the semiconductors and come back and place them on the board. But sometimes these systems are expensive because of the image recognition, and well, we have to start looking for a low-cost alternatives for this kind of systems. The idea was to create our own system for future researchers, but the idea was to start with a platform that is going to have a mechanical system mounted on a frame with it's going to be moved with 2 stepper motors, which are going to be controlled, and they're connected through they're shaft connected with bolt screws, but very precise, and each step instead of moving portions of an angle, it has a bigger resolution, because not only the part of the angle it can move, but the amount of movement that it has because of the bolt screw that is shaft connected, as I said before, from the stepper motor to the mechanism. So we can have a very high precision of movement in each axis we have. Right, this platform is mounted, as you can see, on a metallic plate that is going to have some holes that we can replace and remove the platform and start new aligning according to the necessities of the system that is going to be aligned. And then, well, we can use it to align several systems that need to be aligned again. And basically what it has, it is a system connected to the computer with a human interface, with a human machine interface connected to MEJA, the fast development board, which is connected to the stepper motors driver to control the movement. And then to check if the align is correct or it's in its place, we use a laser, and then this laser sends its laser beam. And since we already know the transmission power, we are sure that we're going to have that signal, that amount of power at the end of the signal. So we have a receiver, a power meter, so it's going to tell us that if we are in its right position, so we will get the whole power transferring. And well, the system is telling us if the power is going up, is going down, so we can assume that aligning is getting better or it's getting worse. Well, as I said before, you can see in this picture the different stages of the system. For example, in the computer, you will have the human machine interface connected to the MEJA board. The MEJA board is connected to the stepper motor drives, and the stepper motors are shaft connected by means of ball screw connected to the axis of the platform. So, well, the platform, it's also connected to a laser transmitter, and the laser goes through a set of mirrors, and they're gonna split the signal, and they're gonna send it in different directions. But the laser is gonna go through a hole in a specific spot, and once that the laser beam is going through that spot, and we get the biggest amount of laser beam powered, we're gonna know that the system is already aligned. We can see this lecture on another system. I mean, in another device that it tells us the laser power. The system, because of the stepper motors and the ball screw, show a very high accuracy when moving, thanks to its micro movements, and it's suitable for aligning devices that require a very high precision with its functioning. For example, the displacement that we can measure using a vernier device was of 0.01 millimeters during a aligning test. And well, new design of aligning is presented for a pick-and-place machine and other systems that need to be aligned. It's going to be a good alternative, which is not that expensive and can be used in different systems. Well, the conclusion that we can have from this work is that the high accuracy aligning system, well, is already achieved using a laser beam instead of a reconnection system. And the advantages of this is easily being reconfigured and updated at low cost. Like I said, well, we can add remove different stages and improve it. And due to the system performance, micro movements are ensured and performed thanks to the micrometric screw, and in this case Michelson-Morley interferometer was developed and manufactured for this platform. Thanks for watching. In this case, author want to thanks to University of Guanajuato, PRODEP, and the University of Querétaro for all the support that we got from them, and I hope you find this interesting. So if you do, don't hesitate in contacting us to try to share this information with you. And thanks for watching again. Bye.